Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you the concept related to the power series from the year 2005 to 2024. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the two different playlists. One is for the IIT Jam and you can see the various questions related to the mathematics and statistics all are available in this playlist. Second playlist is the CSIR net and in this playlist you can see the various lectures and the complete solution of the previous year questions with the help of shortcut tricks. You can follow and subscribe my YouTube channel for the more updates. Whenever we are talking about the power series, if you see any question in the examination related to the power series, the first thing come in your mind is always to calculate the radius of convergence. How you can calculate the radius of convergence? If you have the power series this form, C is called as the center of the power series, an is called as the coefficient of the series. Find coefficient of the power series. Then you can find the radius of convergence by using this equation, 1 over limit supremum an raised to power 1 over n. This 1 over n is the power of this quantity. In this case, the power is my beta of n. Instead of the 1 over n, you can write is as 1 over beta, or you can also write this quantity is an over 1 over beta n. That's on your choice. Second way, you can find the radius of convergence by using the ratio test like an plus 1 over an or an plus 1 over an raised to power 1 over beta. If you have the power series like of this manner, an x raised to power n square, then your radius of convergence is computed instead of the an 1 over n, it is 1 over n square. Fine. If it is a n cube, then you can write as n cube. If it is a n factorial, you can write as a n factorial. Once you can find the radius of convergence, then you can write the answer of center is C, interval of convergence less than R, interval of divergence greater than R. However, on the point when x minus C is equal to R, I can substitute this value in the given series. Your power series becomes this expression. Then you can check whether this series is my convergent or divergent. You can apply either the p test, you can apply either the limit comparison test, you can apply either the root test, you can apply either the ratio test or any other test which is related to the convergence of the infinite series. If you obtain that radius of convergence is 0, then the series is convergent only at the center of the series. On the other hand, if R is my infinity, the series is convergent for all x. If you prove that the series is convergent at the point alpha, then the series is also convergent absolutely for all those x which is less than of alpha. Similarly, if it is a divergent, then you can see it is also divergent for greater than alpha. If you are the student of the IIT JAMS group only, whether it's the mathematics or the statistics, then you can join this group by scan and join of that. Make sure you are the only student of the IIT JAM. CSIR net student don't join this group. There is a separate group which is available in my videos. Now look at this first question. Find the radius of convergence. Your first target is to check what is the power of this n. So that means your radius of convergence will be limit supremum of an raised to power 1 over n. What is my an? An is 1 plus 2 over n raised to power n square. Now can you find the a raised to power n of 1 over n? It is 1 plus 2 over n raised to power n. Clearly say it converges to the e square as n approaches infinity. You can also see that this is the 1 raised to power infinity form. You can multiply this e raised to power 2n into n. So that's the e square. So what's the right answer of this problem is 1 over e square is the right answer. Look at the second question. It is given that an and bn are the two positive sequence such that n into an is less than bn is less than n square of an. If the radius of convergence of the power series an is my 4, so that means 1 over limit an, it is my n, so it is 1 over n is given to be 4. Then your target is to find the power series of bn. Fine. So very simple. I can take an 1 over n on the both side. It is my 1 over n. It is less than of bn of 1 over n. it is n raised to power 2 over n, an of 1 over n. Fine. Make sure student you must remember this result. Limit n approaches infinity, n raised to power 1 over n is always 1. So this limit is 1. Take the limit as n approaches infinity. This number is my 1 over 4. 1 into 1 over 4. This limit is my limit of bn. This is again 1. This is 1 over 4. So therefore, what is the limit of the bn? 1 over n. It is my 1 over 4. So can you find the radius of convergence of the bn? It is 1 over 4. That is 4 is the right answer. Hence, the series is center is my 0. The series is convergent for all those x which satisfied this property only. So now you can see that the first option is the correct option. X is greater than 2. If I choose x is 7, which not satisfied, cross, does not converges for any x which is greater than of. So if I choose x is my 2.5, it is convergent, but he said does not convergent. Does not convergent for any x which is less than of the 2. If I choose x is 1, it's satisfied. This option is cancelled out. So only option A is my correct answer. I hope you can like, comment and subscribe my YouTube channel. Find the radius of convergence of the power series x raised to power n. Always remember student, whenever you will see the expression of minus 1 raised to power n, fine, you always break into the two component. One is when n is even, second is when n is odd. What will happen if n is even? This component will be my twice, fine, this value will be 0. When n is odd, this number is 0 and this number will be my twice. Then your target is to find 1 over limit supremum absolute value of an, because the power is n only, so it is 1 over n. Now can you find the limit of this case? What will happen if you find the limit of infinity? Firstly you have to take an power 1 over n. Fine. So what will happen? An raised to power 1 over n. So this number will be 2 raised to power 1 over n divided by 2, 2 raised to power 1 over n divided by 3. Now if you take the limit as n approaches infinity, so this expression will be 2 raised to power 0, 1 and it is 1 over 3. Which one is the supremum? So clearly say this number is my 0.5, this number is 0.33. This limit is my supremum. So I can substitute this number 1 over 2. So the right answer is 2 is my correct answer. Always remember, whenever there is a question of minus 1 raised to power n, always break into the two components. Consider the power series. Clearly say an is my 1. Then the radius of convergence is my limit an 1 over. Now you can see the power is n factorial. So you can write this as n factorial. So can you find this limit? 1 raised to power 1 over n factorial as limit n approaches infinity. So 1 over n factorial when n approaches infinity, that means 0. 1 over 0 is my 1 is the correct answer. Let Px is the polynomial of real variable x of degree k. Consider the power series and find the radius of convergence of the fx. I will tell you the two different methods for this problem. The first method is the shortcut tricks. What is the shortcut tricks is, if you have the power series this such that r is my radius of convergence, then pn into an into zn, where pn is my polynomial degree, is a polynomial of degree, any degree, say k, then this also has the radius of convergence r. That means both are my same. Fine. These are shortcut tricks. Now if you compare this series, can I write this series an is my 1? Fine. Now can you find the radius of convergence of this series? It is 1 over 1 raised to power, so it will be my 1. So if this series has a 1 radius of convergence, Pn is a polynomial, then this series has also the radius of convergence 1. This is one first method you can find with the help of the shortcut tricks. Second method, if you are unable to use the shortcut tricks, look at that Px is a polynomial of degree k. So I can choose any number k. So say k is equal to 1. If I choose k is equal to 1, then you can see that the second and the third options are same. So then instead of the 1, I can choose k is my 2. Now all the options are different. So px is my x square. Now your polynomial series will be n square into z raised to power n. So can you find this an? An is my n square. So what is the limit of an? 1 over n. So it will be n raised to power 2 over n. So as I told you, limit n approaches 1 over n is always 1 as n approaches infinity. So this is my 1. So therefore radius of convergence is 1 over limits infinity, that is a 1. Again you can see 1 is the right answer of this problem. I hope you can like, comment and subscribe my YouTube channel. If you put a comment, like and subscribe, I will upload more videos related to this IIT JAM and the CSIR net examinations. Let an and zn be the convergent power series such that an plus 1 over an is my r. P is a polynomial of degree k. Again you can apply my shortcut tricks. Whatever the radius of convergence of this series, find the same power series Pn, because Pn is a polynomial, then you can say this series is my R. Fine. Now what is the radius of convergence of this series? It's a convergent series, then the radius of the convergent is 1 over limit an plus 1 over an. So that will be my 1 over R. So that means this series has the radius of convergent 1 over R. So this series has also the radius of convergent 1 over R. But you can see that none of the option is correct. Fine. But if you look what, because R can be any number. So if I taken R is my 1, because none of the option is correct. But the most appropriate answer, you can see this is the most appropriate answer. Fine. Otherwise the correct answer is 1 over R. So you can see that none of the options is the correct in this option. But if you find the most appropriate, only the case when R is equal to 1 is the A is the answer. Otherwise the correct answer is 1 over R is the right answer. The coefficient of z raised to power n in the power series. Okay, so firstly now I can tell you again the shortcut tricks for you. Whenever you have the power series an x minus c raised to power n, such that an will be my nth derivative at the point center divided by n factorial. Fine. Now what is the an? An is my coefficient of power series. Now you can see x raised to power 4. That means n is my 4. Fine. Then the coefficient is my a4. So your target is to find the fourth derivative. What is the center is? 0 divided by 4 factorial. So what is the f? F is given to be my e raised to power sin x. Can you find the fourth derivative? The first derivative is e raised to power sin x into cos x. What is the second derivative? I can use the product rule. If you apply the product rule, you will get this expression, that is the sin is cos square x and cos is my sin x. Fine. If you find the third derivative, again it's a product rule. E raised to power sin x I can take as a common. So it will be my sin into cos. It's a cos cube x. It is sin x into cos x. I can write as a sin of 2x divided by 2 minus sin of 2x minus cos x. Fine. I use the product rule. First function derivative of second, second function derivative of 1. And now you can see that I can combine these two expressions. I can write this is my simple 3 over 2. Fine. Now you can find the fourth derivative. So fourth derivative is e raised to power sin x. So sin x is a cos x. So I can multiply this term is by cos x minus 3 over 2 sin of 2x cos x minus cos square x plus e raised to power sin x into derivative of this. So it's a minus 3 cos square x sin x minus 3 cos 2x plus sin x. Now you can substitute this value. What is the value at the point 0? So e raised to power 0 1, 1 minus 0 minus 1 plus 1, sin 0 is 0, cos 0 is 1, sin 0 is 0. So the answer is minus 3. So your required answer is 3 over 24 minus 1 over 8 is my right answer. That is minus 0.125 is the correct answer. The interval of convergence, now the interval of convergence, x minus c is less than r. Fine. But make sure, firstly, you have to make coefficient of the x to be the 1. So I can take on 4 raised to power n is a common. I can write this is my 9 minus 3 raised to power n also. It is x minus 3 raised to power n over n square plus 1. Fine. There are the two methods how you can find the interval of convergence. First way is you can consider an is my 4 raised to power n, 9 minus 3 raised to power n square plus 1. Fine. And find the radius of convergence. I can find a raised to power. It is 4. It is 9 raised to power 1 over n minus of 3. I can take an n square as a common. Then it is my 1 over n square. Fine. Now take the limit as n approaches infinity. This is 1. This is minus 3. This is 1. This is 1. That is a minus 4 over 3. So therefore, your radius of convergence will be 1 over absolute value of this quantity. That is 3 over 4. So I can substitute this expression. X center is my 3 less than 3 over 4. So if you open this bracket, it will be 9 over 4 is less than x is less than 15 over 4. So these two options are cancelled out. Now whether the equality appears or not, now clearly say at x is equal to 15 over 4. Fine. We will see whether at x is equal to 4 series is convergent or not. I can substitute this value in the given expression. It is minus 1, or you can substitute here. That is the same problem. This is 9 minus 3 raised to power n, 3 raised to power n square plus 1. So this will give you minus 1 raised to power n, 9 n square plus 1. So clearly say this series is my convergent by using Leibniz test. So therefore equality is my convergent. Yes, D option is the right, B option is the cancel out. Fine. This is the first method. You can solve it with a very lengthy procedure. But what is the second method is? The second method is instead of finding the radius of convergence, just look about the options. Fine. Now you can see 14 over 4 and 15 over 4. So firstly, I can check about 14 over 4. I can substitute this value in the given series. This will be my 1 over 9 minus 3 raised to power n. 14, that's a 2 raised to power n over n square plus 1. So that will be 1 over 9 is outside, minus 1 raised to power n, 2 over 3 raised to power n, 1 over n square plus 1. Clearly say this series is again convergent by using the Leibniz test. So that means at equality the series is convergent. So the less than sign is cancelled out. Fine. Now we will see at the 15 by 4. Once you substitute 15 by 4, your series becomes 1 over 9 n square plus 1 minus 1 raised to power n. Again, this is my convergent by the Leibniz test. So less than sign is cancelled out. Now, out of these options, which one is the correct? Because 15 over 4 is greater than of the 14 by 4. So therefore, this option is also cancelled out. Because at both the points, the series is convergent. So the largest interval is only my D is the correct answer. Okay, look at this one. The radius of convergence of this power series. An is my n factorial. So what is the radius of convergence? 1 over limit supremum an 1 over n square. Fine. Make sure student, if you are using the limit, if you are using like an plus 1 over an, fine, instead of the n square, then your answer will be wrong. Why? If you find the limit as n approaches infinity, what will happen? This is my n plus 1. So that will go to the infinity. So your radius will be 1 over infinity is 0. But the right answer of this problem is not a 0. Why this is wrong? Because this is not x raised to power n. This answer is 0, fine, but this is for my power series only n. But this is not for the n. Fine. So this option is cancelled. How you can solve that? You can see 1 over limit n factorial over 1 over n square, and clearly say the limit of this value is my 1. How? You can see I can write the n factorial is n minus 1, n minus 2 up to the 1. I can put 1 over n square on each term, that is 1 over n square. I can take an n common, 1 over n square, fine, and so on. The last term is 1 raised to power 1 over n square. Now if you take limit as n approaches infinity, what is that? It is n raised to power n is 1. So this number is my 1. This number is also 1. This is also 1. Last is also 1. So this limit is my 1 over 1. That means 1 is the right answer. So make sure, student, if it is n square, you have to write as a n square. If you look like this manner, then your answer is 0. That is a wrong option. I hope you can like, share and comment on this video as well. Okay, look at this another one. Find the radius of convergence of this series. So firstly, I can solve for the fz. What is my an? N into log n. Power is my n. Fine. So what you can do, I can take an either an plus 1 over an or an raised to power 1 over n. That's on your choice. But I can see that this an plus 1 over an is quite easy for this case. Fine. Now if you take an n approaches infinity, this value will be my 1. Fine. So the expression becomes log n plus 1 over log of n. It is my infinity by infinity form. I can apply the L'Hopital rule, n plus 1. So what is that? Again is infinity by infinity. It is my 1. So therefore the radius of convergence will be 1 over 1. Small r is my 1. Fine. Now for the capital R, what is the capital R is? That is corresponding to the G. So what is my an? E raised to power n square over n. Fine. Clearly say again it is n. You may use as 1 over n because I know it is n over n raised to power 1 over n. If you take the limit n approaches infinity, this value will be 1. This value will be e raised to power infinity, that is infinity. So what is the radius of convergence? 1 over infinity is 0. So r is 0, small r is 1 is my correct answer. Don't forget to like and comment on this video. If you want, I can upload more videos for you. Px is a polynomial of degree d, then the radius of convergence. Again, you can use the same shortcut tricks. What is the shortcut tricks? As I tell you, if this series has the radius of convergence r, then this series has also the radius of convergence r. If you compare this series, what is my an? An is my 1. So can you find the radius of convergence for this series? Limit an, because the power series has the power n. So what is the answer of this? 1 over 1. So this series has a radius of convergence 1. This series has also the radius of convergence 1. This is the first method. Fine. Otherwise, you can see that it's a polynomial of degree. So I can assume px is my x square. So what is my an? An is my n square. What is the an raised to power 1 over n? It is n raised to power 2 over n, which converges to the 1 as n approaches infinity. Again, you can find the radius of convergence is 1 over 1. Fine. But as I told you the shortcut tricks, that is quite easy for you to get the answer in a couple of seconds. The radius of convergence of this series. What is the an? 1. So what is the radius of convergence? 1 over limit an raised to power 1 over n square, because my series is in terms of the n square. So what is the right answer of this problem? Limit 1 raised to power 1 over n square as n approaches infinity. So when n approaches infinity, it is my 1 raised to power 0. So 1 is my right answer of this problem. You can see that a couple of seconds you are needed to solve this problem. Don't forget to like and comment on this video. If the power series convergent for this and divergent, then what is the value of the C? What is the C? C is basically the radius of convergence. So can you find the radius of convergence? An is my n factorial over n raised to power n. Fine. How you can find the radius of convergence? So you have to find a, because the power is my 2n. You start with the 1 over 2n. So it will be n factorial raised to power 1 over 2n divided by n raised to power 1 over 2. Fine. Is it okay? If you taken 1 over, it's a 1 over 2. Now clearly say what will happen. Because you are unable to compute the limits, or otherwise I can use this expression an plus 1 over an. So what is the an plus 1 is? N plus 1 factorial, n plus 1 over n plus 1 into an. So n raised to power n factorial. The power is, coefficient of this is my 1 over 2. Now can you find this limit? N plus 1 will be cancelled out. 1 n plus 1 will be cancelled out from this component. So it is only my this expression. Fine. Now can you solve this? I can take an n as a common. So I can return this is 1 over 1 plus n raised to power 1 over 2. So what is the limit of this component? It is my 1 over e. Is it 1 over? Yes, it's a 1 over e of this value. So therefore, radius of convergence is limit an plus 1 over an. So that will be my root e is the right answer of this problem. You can use 2.718. That will be my 1.655 is my correct answer of this problem. The radius of convergence of this power series. So again, your an will be 2 raised to power 2n. So my radius of convergence, limit supremum an, because the power is my n square. So it is 1 over n square. So 1 over limit. What is the 1 over n square is? 1 n will be cancelled out. It is a 2 over n. Is it okay? So now if you substitute as n approaches infinity, so that will be 1 over 2 raised to power 0. 1 is my correct answer of this problem. Fine. Remember student, if you are using this formula 1 over n, fine, then your answer will be wrong. You can see that limit, what is the an of 1 by n is 2 raised to power 2. That means 1 over 4. Then your answer will be 1 by 4. But the actual answer is 1 because of this n square expression. If the power series convergent at 3, if the power series is convergent at x is equal to 3, it is given that, then the series also convergent absolutely. What is the shortcut fix? As I mentioned you, if the power series is convergent at alpha, then the power series is also convergent for all those x which are less than of alpha. Fine. Or you can also say that which is convergent at the center. Fine. So now the center in this case is my 0. So that means this power series is also convergent at my 3. Now based on this step, you can check that minus of 2 modulus less than 3 is satisfied. Convergent minus 1 modulus satisfied, but he said not absolutely. It is absolutely convergent. X is equal to 1. 1 is less than 3 is satisfied, but it is said not. Minus 2. What is the case for the divergent? It is greater than of the value of alpha. So that means, but minus of 2 modulus is my plus. It is satisfied. That means it's a convergent, but he said divergent. This option is cancelled. A is my right answer. You can see that within the couple of seconds, you can solve the problems. Which of the following condition ensure the power series defines the entire function? First of all, we all know that the entire function has a radius of convergence infinity. Fine. Now we can see about that which of the following has a radius of convergence infinity. What does the meaning of the first case? Power series convergent because the center is my 0, convergent for every c. That means what is the value of the every c? Less than of infinity, because the power series is convergent at 1, power series is convergent at 2, power series is convergent at 3, and so on. So this is convergent for all z. That means what is the domain of this z? Complete C. So the radius of convergence is my R. R is my infinity. Yes, this series defines the entire function. Look at the second one. convergent for every r, every z in the real number. So if it is convergent for z is equal to 1, if it is convergent for the real number 2, what is the maximum value of r? Again infinity. So again you can see the radius of convergence is infinity. Yes, it is convergent. Look at the C option. It is convergent for every z 2, 4, 8, 16 and so on. What is the largest number of the 2 raised to power n form? Again it's infinity. Yes, it is convergent for all infinity. That means r is infinity. Fine. Because your target is to find the supremum. Find the supremum is my infinite. Now look at the last case. When you take n is 1, it is 1 over 5, then 1 over 25, then 1 over 125 and so on. What is the supremum of this? 1 over 5. So that means this power series is convergent for 1 over. So that means r is my only 1 over 5. So that means r is not equal to infinity. That means it is not always convergent for all z. That means it may or may not define the entire function. So the right answer is A, B and C are the correct answers. The radius of convergence of the power series. Again it's n square. So your target is to find limit an of the n square. But you can see that an is not properly defined. This is the recurrence relation. So can I substitute this value? What is the an minus 1? Again I can taken from this case of a of n minus 2. Again I can substitute the value of n minus 2, n minus 1. So what is the a of n minus 2? It is minus of n minus 2. And similarly for so on, the last expression will be a0. So that means 3 raised to power 1 into a0. So what is the a0? a0 is my 1. And you can see I can write this expression is minus, I can take it as a common, n minus 1, n minus 2 up to 1. a0 is my 1. So which is the expression of this? It's an AP series. The sum will be n plus 1 over 2. Now I can substitute this limit. It's a limit an raised to power 1 over n square. 1 n will be cancelled out. So 3 raised to power minus half n plus 1 over n. So what is the limit of this? It is 1 over 3 raised to power minus half into 1. So that will be root of 3 is the correct answer of this answer. You can see that it's a very simple. Your target is to find the value of an from this recurrence relation. Dear student, don't forget to like, comment and subscribe my YouTube channel. Okay, again the radius of convergence. Fine. So your target is to find the limit supremum an, because the power is my 1 over 2n. So it is my 1 over 2n. Fine. Now you can substitute this value an. So what is the an raised to power 1 over 2n? It is minus 4 raised to power 1 over 2 divided by n raised to power 1 over 2n, n plus 1 raised to power 1 over 2n. Fine. This value again we use the same result. N raised to power 1 over n is my 1. This number is my 1. This number is iota. Fine. This is minus, I can write this is minus 4 raised to power. I can take an n is common. So n over 1 over 2n is common. 1 plus 1 over n, 1 over 2n. Now clearly say this limit is my 1 as n approaches infinity. This limit is also my 1. So this expression is my minus 4 raised to power 1 over 2. Fine. But we need always as a positive value. So this number is my positive. So that is my 2. So I can substitute this answer. 1 over 2 is my right answer of this problem. Okay. Look at this another one. F is the rational number of the complex variable, then the radius of convergence of the Taylor series. Shortcut tricks. Firstly, because in this case, do you have the an? No. Fine. You don't have the an, so how you can find the radius of convergence? So the radius of convergence is my center minus pole. What is the center is? At which point you want to calculate? 1. What is the pole of this complex function? Pole means the denominator is 0. So the pole is 0. So the radius of convergence is my +1 is the right answer. You can see that within a couple of seconds you can solve this problem easily. Now again the radius of convergence is given to you. You have to find the radius of convergence. Limit an. Now the power is n, so that is 1 over n. So can you find the a of n of 1 over n? So there are the two cases. So that will be 1 over 3 and it is 1 over 4. Can you find the supremum of this? Or you can find the firstly limit. Limit is again the 1 over 3 and 1 over 4. Now can you find the supremum of this? So which one is the supremum? This is 0.33 and this is my 0.25. The supremum is 1 over 3. So if you substitute this value, it is 1 over 3. So the answer is 3 is my correct answer. You can see that within the 15 seconds, you can solve the problem in a very simple manner. Let Cn is the sequence of the real numbers such that this limit existence and it's a non-zero. If the radius of convergence of the power series is my r, Cn x raised to power n, which has the radius of convergence is my r, then your target is to find the power series convergence. Now clearly say this n square is my p of n, is a polynomial of degree n. So that means this series has also the same radius of convergence of the previous one. So that is equal to C is my right answer. You can see that within a couple of seconds you can solve this problem. If somebody will give you find the radius of convergence of this series, fine. Again you can see this is my polynomial. Fine, it's a polynomial, so that this also has the same radius of convergence as of this original series. So that's again same shortcut tricks you can apply that. If f from -1 to 1 is such that nth derivative exists and it is bounded for every n and for every x, then f has the convergent power series in the neighborhood of this. Very simple. You can see that can you define any value, any function f so that whose derivative is my bounded, that is a my 1. Which function come in your mind which upper bound is my 1? Upper bound is my 1. There is a sine and cosine. So if I consider the function is my sine x, for example, fine, definitely the nth derivative exists over the domain -1 to 1, fine, and the nth derivative is also less than equal to 1. So this function satisfied by this property. Now, can you write this as power series? Yes, you can write this as a power series x minus x cube over 3 factorial and so on. And the sine x, we all know sine x is a power series and it is convergent for all x belongs to the R. Fine. But in this case, my domain is -1 to 1. So it is convergent for every x belongs to the -1 to 1. Fine. It is convergent for every x which belongs to the -1, 0. Yes, but the word is only mentioned. That's why this is cancelled. There is no x which belongs to this. That's a cancel. It is convergent for this case. Fine. But he said only. So that's why this option is also cancelled out. So the right answer of this problem is A is my right answer of this problem. The radius of convergence of this power series. Again, an is my n cube over 4 raised to power n. So what is the radius of convergence? That is 1 over limit an. What is the power is? 5n. So it is 1 over 5n. So I will firstly find an raised to power 1 over 5n. So if you taken an is 5 over n, it is my 3 over 5n divided by 4 over 1 over 5. Now if you consider the limit as n approaches infinity, so again I can use the same result. This limit is my 1 as n approaches infinity. So this is 1 raised to power 3 over 5 divided by 4 raised to power 1 over 5. That means 1. So if I substitute this value in this expression, it is my 4 over 1 over 5 is the right answer. So that means B is my Correct answer. Look at this another one. R is a radius of convergence of the power series, then the value of the R square. If you closely look about that, this series is related to the 1 over 3, 1 over 3 cube and so on. You have the two different series. Fine. So I can write this series into the two expressions. Fine. And you can see the power is, I can write this is my an x raised to power n 0, 1, 2, 3 an. So what is the an? Corresponding to this odd terms. When n is odd, the expression will be my with respect to the 3. So the coefficients are 1 over 3, 1 over 3 square, 1 over 3 cube and so on. Now clearly say I can write this is my x raised to power 0. Fine. Sorry, it's a even. Or the term you can, or n is my even. Fine. So how you can find that? So clearly say if it is a 2, then it's a 2. If it is a 4, then it's a 3. If it is a 6, if it's a 2, then 2. If it is 4, then it's a 3. If it is 6, then it's a 4. So what does it mean? Clearly say that means 1 over, that is a half of this plus 1, half of this plus 1. So that means n over 2 plus 1. Fine. On the other hand, when your n is my odd series, like this 5 terms, so if it is a 3, then it is my 2. If it is power is 5, then it is my 3. If power is 7, then it will be my 4. So clearly say this number is my 5, 3, 2, 5, 3. So that will be n plus 2. No, n plus 2 is not there because it's a 7 to the 8. So that will be, how you can find that? It will be, yes, it is my n plus 1 over 2. 7 plus 1, 8 over 2, 5 plus 1, 6, 3 plus 1 over 4. Now you have the two series. Can you find the limit supremum? Fine. So your target is to find an raised to power 1 over n. So I can write as 1 over 3 is a separate. So this expression I can also write this is into 3. Fine. So if you divide it by 1 over n, so the first expression will be 3 raised to power 1 over 2. This is 3 raised to power 1 over n. And for this case, if you divide it by n, it is 1 over. If you divide by n, half is common. So 1 plus 1 over n. Now take the limit as n approaches infinity. This expression will be 1. It is 1 by root 3. And this expression will be 1 by root 5. And what will be the supremum? This clearly say this is my supremum. So that means the radius of convergence will be 1 over limit an of 1 over n. Root 3 is my supremum. Fine. And you need the r square. R square is my 3 is the correct answer. Now you can see that it's a recent 2023. R1 and R2 are the radius of convergence of this series and here. Then which of the following statements are my correct? Firstly, we will see about this case. It's convergent for all. So the one way is you can find the radius of convergence. Otherwise, you can substitute the value of the x is plus 1 in this series. What will happen? Minus 1 raised to power n, 1 raised to power n minus 1. So does it a convergent? It is a divergent series because the limit of this is not unique. So it's a convergent over the closed interval 1. Wrong answer. Look at this case. If x is equal to 1, what will happen? This series is my minus 1 raised to power n over n into n plus 1. Yes, this series is convergent by using Leibniz test. Now we can see about the minus 1. Is this series is convergent at minus 1 also? So I can write this is minus 1 plus 1 divided by n into n plus 1. So this series is my nothing but minus 1 over n into n plus 1. So clearly say this series is my convergent by p test or by limit comparison test. I can say it is a 1 over n square. So that means yes, this series is my convergent. So once this is my convergent, what is the radius of convergent of this series? If it is my R2, now clearly say the radius is my 1. The largest interval is my 1. Again, you can see 1 minus center. Center is my 0. Fine. So R2 is my 1. What is the radius of convergence of this case? So again, you can take an an is my minus 1 raised to power n. So what is the an raised to power 1 over n? Is a minus 1. So what is the radius of convergence? Limit of this quantity, that is a 1. So this value has the radius of convergence 1. So both are my same. R2 is my greater than 1. That's wrong because R2 is exactly 1. This is the first method. Second method, you can write it directly. What is the second method is, if you look about these two expressions very carefully, this is my expression say A, this is my expression B. Clearly say the expression B is obtained. How you can obtain from the expression A? Clearly say it is obtained by the double integration of the expression 1. Fine. You can see that if you integrate the first part, what will happen? It is x raised to power n over n. If you again integrate them, it is my x raised to power n plus 1 over n plus 1. And you can see this is the same one. So once, if you have the power series A, if you have the power series B, which are obtained through A either by the integration or by the differentiation, fine, then the radius of convergence of these series are always equal. Fine. So you can find this series because this B series is obtained by the integration from the A. So the radius of convergence are always same. Okay, which of the following an is a sequence of the real numbers such that this convergent at 5. Then this series is also convergent at, again the same shortcut tricks. The center is my x minus 2. If the power series is convergent at minus 5. Fine. So that means this power series is also convergent at less than 7. Now look at the option which will be satisfied. If x is equal to 9, 9 minus 2, 7, it is not strictly less than, so that will be cancelled out. X is equal to 12, 12 minus 2, not satisfied. 5, 5 minus 2, 3, satisfied. Minus 6, minus 6, minus 8, that is the 8 less than 7, not satisfied. C is my right answer of this problem. Fine. The same shortcut tricks as I told you. If the power series is convergent at alpha, then the power series is also convergent absolutely at mod of alpha. But in this case, it is the center is my 2. So I can say it is less than of alpha minus C. Fine. Now, the set of all those x which the power series is convergent. The first method is you can find the radius of convergent, fine, and so on. Otherwise, I can check about the endpoints. From this case, I can check whether x is equal to 1 is convergent or not. If I substitute this expression 1, it is my minus 1 raised to power 3n divided by 2n plus 1 whole square. Clearly say it is a convergent by using Leibniz test because it's a decreasing sequence. Fine, it goes to the 0 and it is a positive here. So that means at x equal to 1 it's a convergent. It's an open interval. That's wrong. Fine. Now we can see about the third. What about x is equal to 3? At x is equal to 3, this series becomes n over 2n plus 1 whole square. 3 minus 2 is 1. So clearly say this series is my divergent by the p test. Why? Or you can use as a limit comparison test. How? You can choose the Vn is my 1 over n. Fine. And it is my divergent. So that means x equal to 3 is my divergent. So that means now there are the two options. We can check about the one option in between them. Fine. So how you can do that? I can simply choose x is say 0. Fine. Now if x is 0, it lies in between. Does it as convergent or divergent? Or you can choose any other number. So what will happen? Now it's a x minus 2. Fine. So that means it is less than of something r. So clearly say it will be my 2 minus r is less than of the x is 2 plus r. So definitely this term must be 2 plus r, but that is not 2 plus r. So the right answer is only C is my correct answer of this problem. Fine. Okay, look at this another one. The power series convergent if, again, first way is you can find the radius of convergence. I will tell you that both methods. What is the radius of convergence? The power is 1 over 2n. It is my 2 raised to power minus 1 over 2. Fine. So it will be my 1 over root 2. So the radius of convergence is root 2. Center is my 0. So therefore the power series is convergent at root 2. So these two options are cancelled out. Now whether the equality appears or not, we can substitute at root 2. If I substitute this expression, it is my 2 raised to power minus n into 2 raised to power minus n. That is my constant. So remember always, shortcut tricks is, as I told you also in my previous lecture, if you have the constant series, say alpha is my constant series, this series is divergent if alpha is my non-zero, and this series is my convergent if alpha is equal to 0. Now you can see that alpha is my 1, alpha is a non-zero, so at root 2 this is my divergent. So that means equality is not there. Right option is only D is my right answer. This is the first method. Fine. There is one more method. If instead of finding the radius of convergence, we will look about the options. Firstly, we will see about the z is equal to 2. We will substitute in the given expression. It is 2 raised to power minus n. It is 4 raised to power or 2 raised to power 2n. So that will be 2 raised to power n. So clearly say this is my GP series, while the radius of while the common ratio is my 2, and clearly say this is my greater than 1. That means this is divergent. So that means equality is not true. Fine. If I consider any of the number which is less than of the 2, say 1.5. Fine. If I consider 1.5, so then this number will be 3 by 2 raised to power 2n. Fine. So what will happen? Again, you can see this is my divergent either by using the GP test or by the limit comparison test. And out of these cases, as I told you, if you taken z is my root 2, then this series is my 1, which is divergent. So equality is cancelled out. Again, the right option is only D is my correct answer. Again, the same case. Fine. Again, the same case, your answer will be z minus 1 is less than of the r. Fine. Because this is a 0, because the center is my 1. So first and second options directly cancel out. What is the radius of convergence? An. Fine. Now it's the power of 2n. So my target is to find this number. So 3 raised to power minus half. So what is the radius of convergence? 1 over 3 raised to power minus half. That means root 3. So I can substitute this value is my root 3. Fine. Now we will check about the equality. So at the point z minus 1 root 3, I can substitute this expression 3 raised to power minus n root 3 raised to power 2. So 3 raised to power n. Again, you can see it's a 1. Again, by using the same shortcut tricks which I told you, if it is a constant, this is a divergent if alpha is my non-zero. So again, this is my divergent. So that means equality does not hold. Only D is my correct answer. Look at this another one. The coefficient of this in the Taylor series. You can see your target is to find the coefficient of this. That means your target is to find A2. And what is the coefficient of the A2 in the power series? Second derivative at the point 1. Fine. So what is my fx? F is my x into ex. Can you find the first derivative? It is my x plus 1 into ex. Can you find the second derivative? It is x plus 2 e raised to power x. So therefore, the second derivative at the point 1, it is my 3 of e. Now I can divide it by 2 factorial. This is my a2. 2 factorial is my 2. So C is my right answer of this problem. Again, your target is to find coefficient of this. That means your target is to find the A3. Fine. So that means your target is to find the third derivative at the point pi over 4 divided by 3 factorial. Fine. So how you can do that? Firstly, I can simplify this expression. It's the 3 sin x. I can open this is a cos A cos B. Fine. Minus sin A sin B. So I can take an f is my 3 divided by root 2 is common. Fine. This is sine into cos x. I can multiply 2 and divide it by 2. So it is my this expression, and this is my sine square x. Now your target is to find the third derivative. So first derivative will be 3 by root 2 is common. This expression will be cos of 2x minus 2 sin x cos x. That will be my again sine of 2x. Second derivative 3 divided by root 2. It is minus 2 sine of 2x minus 2 cos of 2x. And finally, we can find the third derivative. It is 3 divided by root 2. It is my minus 4 cos of 2x minus minus plus 4 sine of 2x. Now at the point pi by 4, third derivative pi by 4. This value will be 0 because cos pi by 2 is 0. Sine pi by 2 is my 1. So this number is my 4. Fine. So that will be my 12 divided by root 2. So what is my A3? I divided by 6. So that will be 2 divided by root 2. That will be my root 2 is the right answer of this problem. So you have to write up to the 3 decimal places. 1.414 is the right answer of this problem. Next one is if 0 to x e raised to power minus has the power series expansion x raised to power 0 e raised to power minus t square cos of t, which has the power series expansion of this form, then your target is to find this A5. Fine. That means you can equate the coefficients. So what is the A5? When it will be the A5 appears, because this is the integration of this. Fine. So A5, that's the coefficient of the x raised to power 5. I can equate the coefficient of the x raised to power 5 on the both sides. So when it will be the coefficient of the x raised to power 5, if I found in this case the coefficient of the x raised to power 4, because once we integrate them, the coefficient of the x4 becomes the coefficient of x raised to power 5. So let's see. If you open this bracket expansion, it is 1 minus x square plus x4 over 1 minus x minus x square. Fine. Plus cos of, what is that? Cos of the x series. It is 1 minus x square over 2, x4 over 4 and so on. So 1 minus x square over 2, x4 over 4 and so on. Fine. Now since I need the coefficient of the x raised to power 5, when it will be the coefficient of x5, when you integrate them, this is the coefficient of the x cube. This is the term which is the coefficient of the x5. Fine. So if you integrate them, it will be 1 over 2 factorial. Again, from this case, it is 1 over 4 factorial. Is it fine? So that is the, what is the integration of this? Is the integration of t raised to power 5 into, and it's the t raised to power 5 of this. So what is my a raised to power 5? The coefficient is 1 over 5 is common, 1 over 2, 1 over 24. So that means 1 over 5 is outside, 24 is the LCM, 12 plus 1 is a 13. So the answer is 13 divided by 5 into 24. 13 divided by 120 is my right answer. Fine. Okay, look at this another one. Find the sum of the power series. That's a very interesting question and the easiest one. Look at that. Firstly, I can write the 1 in the similar manner. I can start from the 1 to infinity. Minus 1 raised to power n minus 1 n square x raised to power n minus 1. Because if I start from the 1, what will happen? X raised to power 0, 1, this is 1, this is 1. That's a similar quantity. Fine. Now, whenever your target is to find the sum of the series, try to think about the case of the differentiation always. Fine. It means this is my n square and this is my n minus 1. If I consider the term x raised to power n, and if you find the differentiation of this, it will be my x of n minus 1. Is it fine? But because we need a n square, when it will be the n square? If you find the second derivative, fine, then it will be n minus 1 x of n minus 2. Is it okay? Fine. Now what I can do is I can replace this n square. I can replace this n square to be n into n minus 1. So that means I have to add 1n also. Fine. Now I can open this bracket. This is n is equal to 1 to infinity minus 1 raised to power n minus 1 n into n minus 1 x raised to power n minus 1 plus summation n varies from 1 to infinity minus 1 into n x raised to power n minus 1. Fine. Now firstly I can think about this quantity. Fine. So what will happen? I can write also, because these two quantities are same, so I can write this value is my x only. Fine. Now clearly say, if you consider this expression minus 1 raised to power n, what is the derivative of this expression? It is my n minus x raised to power n minus 1 into minus 1. So that means there is a need of the one negative sign. Fine. I can replace this positive sign to be negative sign. Fine. So it means this expression is my d by dx of minus x raised to power n. I will solve this expression. Fine. Now since this is because x is lies between 0 and 1, this is a convergent series, so I can write the differentiation and summation part separate. Fine. From 1 to infinity. Now you can see that this is my GP series. So what is the sum of this? Minus a over 1 plus x d by dx. So that will be minus minus plus. So that means the derivative of x over 1 plus x. Now if you find the derivative of this, how you can find the derivative? Either you can use the product rule, u over v, or I can write this expression in this manner. So this expression is my 1 over 1 plus x. Is it okay everyone? Fine. So what does it mean is, this expression, the sum is my plus 1 over 1 plus x square. Fine. Now the same way I can found for the second part, because it is n into n minus 1, I can replace this value as n minus 2. So that means I have to add 1x. Fine. Now since this is my n minus 2, I can also add as n minus 2. Then it means I can add one negative term also. Fine. So this expression I can return like n minus 1 minus x n minus 2 from 1 to infinity. Again you can see, because if you consider this expression twice differentiation, then this is the same expression, that is a minus second derivative of this expression. Fine. Now again you can see this is a GP series. I can found it sum as second derivative of minus x 1 plus x. Again this is minus minus plus, so I can write this is the second derivative. How you can find the second derivative of this, which is 1 over 1 plus x. So can you find the second derivative of this expression? I can write it directly here. So this is my x. First is a 0. What is the first derivative of this? Is a 1 over 1 plus x square. Second derivative is my minus 2 over 1 plus x cube. Fine. Plus 1 over 1 plus x square. So that means the denominator is the cube. Power 4 cancel out. Power square cancel out. Now you can simplify this. 1 plus x cube is a common, LCM, minus 2x plus 1 plus x. So 1 minus x is my right answer of this problem. Fine. So this is little bit difficult, that's fine, but you need to be find the expression of this series. So this is the way you can solve the power series questions in a very simple manner. I hope you can like, share and comment on this video. Best of luck students, and don't forget to subscribe my YouTube channel. Thank you very much. Happy learning.